All right, welcome back. This is my 5th video I'm making today, so I'm pretty excited. And I want to do this problem that was extra credit on our quiz. And so with the integral, I think of x cubed times cosine of x squared dx. And if we look at it, there was a hint to use substitution. And I know you probably see that there's an x cubed and an x squared there. And you might try letting u equal x cubed. But if you think about it, the derivative of this is never going to cancel with the inside of this cosine function, right? So it's not going to be true that, like, let's just think about it, right? If I do cosine of 2 and then I multiply by 1/2, that 1/2 doesn't cancel out the 2 or anything like that. And so that sort of simplification isn't likely to help or happen. However, if I look at this and I say, man, the only real integral involving cosine I can really do is cosine of u, or cosine of x. And so why don't I let that be u? And if I go through my process, so u equals x squared, du will be 2x dx, and then dx will be du over 2x. Then what's going to happen in this integral when I rewrite it is I'm going to get the integral of x cubed times cosine of u times du over 2x. And then I'm going to get, well, one of the x's is going to cancel, so I get the integral of x squared cosine of u du, which is then going to be the integral of, well, hey, x squared, that's u again. And so that's going to be the integral of u cosine of u du. And so now we have a problem here, and I look at that and I say, aha, integration by parts can help us out here. And so we do have a little bit of a problem that we've got now the letter u in there. So we've got u times the cosine of u. And so what I'm going to do is I'm going to set up my, my box. And instead of using u and v, since we've already used a u and it would be confusing, I'll still set up my dv and v. And for instead of u, I'm just going to use w. So I'm going to set w equals u, and then I have dw is going to be 1 du. dv is going to be cosine of u du. V is then going to be sine of u. And now if I work out this integral, let's switch back to blue, I now get the integral of, I'm going to get, let's just draw our cross products. I'm going to get our product of, in this case, w times v, so that's going to be u times the sine of u. And then I'm going to subtract off the integral of v dw. So it's going to be the integral here of sine of u du, which is, of course, equal to u sine of u plus the cosine of u plus c. And I've just noticed that we've made a typo in this work, and we're going to go back and check everything together in 1 second, but maybe you've already noticed the mistake I've made. So if you want to pause the video and look for that, you can. And when I go back and I check my work, this is probably good to do. I go back and I check everything. I see I did u equals x squared, 2x dx, divided by 2x. Oh, wait a minute. That division by 2, I don't see that later on in my work. Ah, here it is. Here I divided by 2, but it didn't quite make it down to the next thing. So I made a small error when I made this video. It's about 8 o'clock at night, and I'm getting a little tired, I guess. But we can go ahead and fix that. We can just kind of put that back in. And then at the very end, I can just kind of multiply that by 1/2. The effect is just to multiply everything by 1/2 at the end. so that was a chance to see how to solve this extra credit problem and to see how we could go back and debug our proof and find those little typos. So those are going to happen. They're not, they're not a huge deal. They're something we unfortunately have to look out when we're taking quizzes and things like that. But yeah, by going through and doing that check, I think that will be helpful. So if you want some extra practice, one thing I could charge you to do is to take this answer and take this function and find its derivative. So take the derivative, you'll use the product rule, you'll use the chain rule, and double check that when you get at the very end is the function we started with. So hope you have a great day. Thanks for watching, and see you soon. Bye.